All right, so this question says we find dy dx, find dy dx of dy dx of y is equal to x to the power 3 plus 6, and in brackets we have e to the power 3x. So if you remember, we talked about what is known as the product rule. So the product rule is used to differentiate functions that are multiplying. So any function that is in the format y is equal to u times v can be solved using the product rule. And how do you apply that? We say dy dx is given by u times v prime, which is the derivative of v with respect to x, let's say plus v times u prime. So in this case, we're going to take our u and v as these functions that have been given. So let u be equal to x to the power 3 plus 6, and then v be equal to e to the power 3x. So we can find u prime. U prime is simply just equal to differentiating this, which is x to the power 3. We're getting 3x squared. So 3 times the coefficient of 1 this side is 3, and then x to the power 3, this 3, the power 3 minus 1, we're getting 2. That's why we have 3x to the power 2. And then the derivative of a constant 6 is simply just 0. So u prime is simply just equal to 3x squared. And then we also do the same for v this side. We differentiate v. So differentiating an exponential function, you simply just differentiate the power and then multiply it with the coefficient of the exponential function. Okay, so in this case, when you differentiate 3x, you're going to get 3, and then you write the same format of the function. So in normal circumstance, we use u substitution we use we use substitution not really use substitution. Forgotten the name of the we use a chains rule to do assist to differentiate this expression. So when using chains rule, you make this power as your u. Let me just do a quick one here. So if you have this part here, we say let u be equal to 3x. So du dx will therefore be equal to what? 3. Then our v will therefore be equal to e to the power u. And then dv du will now be equal to e to the power u. So when you differentiate an exponential function, you simply just get the same exponential function if it's not raised to any function with the variable x. Yeah, so the derivative of e to the power x is e to the power x. The derivative of e to the power any function which is not raised to any power simply just the same e to the power that function. Yeah. So what I mean is, if you have e to the power x, they tell you to integrate or differentiate e to the power x. The answer will still be e to the power x. All right. So let's quickly look at so let us quickly look at this. Let's finish up this one. Yeah, so to find dv dx, which is this part, which is v prime, we use the chains rule by saying dv du times du dv times du dx rather. So dv du dv du is what we found here, which is e to the power u. E to the power u. Then I'm multiplying this with du dx. Du dx is simply just 3. So when you multiply this, you're getting 3e to the power u. But you know to say u is equal to 3x. So this can be written as 3e to the power 3x. So what I did here was just a short format of solving it. Just wanted to show you the correct procedure to follow. So when you have been taught to differentiate an exponential function, what you do is simply differentiate the power and then multiply the answer with the whole function. So this is what we've gotten, and then we're using product rule to differentiate. So we're going to get our dy dx as u. Which one is u? Our u is this one. So we say x to the power 3 plus 6. Then we're multiplying it with what? V prime. So V prime is simply just 3e to the power 3x. And then it's a plus V. V is simply just equal to that, which is e to the power 3x. And then u prime. U prime is simply just 3 to the power x. I mean 3x to the power 2. So here's just a matter of simplifying the expression. So simplifying this, we can multiply this through. So we can say, yeah, but if we want, we can factor out 3e to the power 3x because it's common. This 3 times that, okay, let me write it like this, 3e to the power 3x. Then we open the brackets. So on the first part here, I just want to remain with that, which is x squared plus 6. Then we say plus, if in this expression, we remove 3 and e to the power 3x, I'm just going to remain with x squared. Well, this one is supposed to be x to the power 3, not x to the power 2. It's this one there. Yeah, so this is the final answer. You can just rearrange it properly so that it looks nice. So you say x to the power 3 plus x squared plus 6. So this is what you're supposed to do on the first question. And then the other question says, we differentiate cos x over x. So we differentiate cos x over x. So the thing y is equal to cos x, then everything over x. So for this one, we're going to use the quotient rule because we have two functions dividing. So the quotient rule says that if you have any function that is given the format u over v, to find dy dx of this function, we're going to say v u prime minus u v prime, everything over v squared. So our u in this case is simply just going to be equal to cos x, and then our v is simply just going to be equal to x. So to find u prime, so u prime is simply going to be equal to, when you differentiate cos x, you get negative sine x. When you differentiate sine x, you get cos x. When you differentiate cos x, you get negative sine x. Then when you differentiate v to find v prime, you are getting 1. I mean, when you differentiate x to get to find v prime, you're getting 1. So the derivative of x is simply just 1. Yeah, so we now plug into this expression. So we're going to have dy dx being equal to the value of v is simply just x, and then u prime simply just negative sine x. This is my u prime, and then we have u there, so we say minus u is simply just cos x. Then there's also v prime. V prime is simply just 1. Then we're dividing everything by v squared. V squared is x. I mean, v is x, so we're saying x squared. So this is just now simplifying. So I'm just remaining with simplifying the expression. So simplifying this, we're going to get negative x sine x minus cos x, then everything divided by x squared. So this is the solution to this question. Do you have any questions between the two questions that we've just solved? From the two questions that we have solved, do you have any questions?
No, sir, we can proceed.
All right. Okay. So let's proceed. Let's look at other questions.